And then let's have a look at the deactivation of catalyst due to coking, or the other name is fouling. Deactivation of catalyst due to coking or fouling usually involves reactions that involve hydrocarbon. So hydrocarbons like alkane, alkyl, alcohol, etc., etc., that involves hydrocarbon, that has the C bond. Okay, that's C bond. So due to this, the carbonaceous or the carbon material from the reactions would actually deposit on the catalyst surface. So for example, let's say the reaction, this is initial reaction, looks like it's very clean, the catalyst here is very clean, but over the time, when the reactions happens, the C bond break, the C bond activated, etc., etc. So the molecule, the atom of C would actually deposit on this catalyst, and when it deposit on the catalyst, of course, makin banyak, it will actually cover the porosity inside the internal of the catalyst. So due to this, it will also reduce the catalytic activity because of loss of active sites of the catalyst. This is an example of appearance of catalyst after deactivated. So here is the image of the very fresh catalyst, and after some time of reaction, over the time, it can be seen that the same catalyst is changing color due to coking or due to carbon that really covered the surface and also the internal catalyst pores. And over here, the catalyst palette over here, maybe it can be seen that the catalyst changes in terms of size. So you can see that the palettes first that it's quite narrow, but the size changes significantly. Okay, the amount of catalyst that deposited on the surface over the time actually can be calculated using this theoretical equation. So C of C is the concentration of carbon on surface. A is the fouling parameter, which is a function of fixed stock and reactor time. Means that the fouling parameter has to be calculated based on the feedstock and also the reactor type. T is time, and N is the fouling parameter that usually the value will be 0.5. So theoretically, this is the equation to calculate the amount of catalyst deposited on catalyst surface. Now let's have a look at deactivation of catalyst due to poisoning. So poison molecules, it can be from reactant. Poison molecules, it can be from reactant, or it can be molecules that produce from a product in the main reaction. But usually poison molecules is due to impurities in the feed stream. So these poison molecules actually could react with active sites. So when it reacts, or the other term is irreversibly chemisorbed to active sites, it could reduce the number of sites which is available for reaction. So, for example, this is the image of non-poison active sites, and this is the image of active sites which is already being poisoned by this molecule, and meaning that the poison active sites cannot really function really well to the main reactions. This is another example of poison molecules which can be found in petroleum feedstocks. So, example of poison molecules are in petroleum feedstocks are sulfur, lead, other components like phosphorus. So, because of these poison molecules, it actually would affect the active sites here. Okay. So it means that it will mencemarkan lah active sites here. So it will degrade the catalytic activity. So another example here, kalau ada phosphorus ni, it will cover all these active sites. So again, it will degrade the catalytic activity. So this is just an example of what happens in the reaction if poison molecule presence in the feed stream. So katalah contoh reactant A, it will adsorb on a surface. So dia akan akan jadi adsorbed A with S right here, and then AS react to produce B with S active sites here. S is active sites and another product C. And then the B would start to dissolve and to produce B, and the active sites here is empty, so ready for another reactant to adsorb on it. So katalah ini adalah reaction without poison. So what happens if the poison molecule presence in main reaction? Jadi the molecule will actually adsorb on this active site. So dia akan terbentuk this molecule of poison with active sites. So bila dah ada poison with active sites ni, dia would hinder or would inhibit the adsorption of reactant. So reaction of poisoning ni can be represented in this figure. First, that A can actually adsorb on active sites. Lepas tu ada P ni, it poison the active sites. Tapi nanti lama-lama, it will poison, more poisoning. And so, the catalyst will be deactivated over the time. So, in summary, what you guys need to know about deactivation of catalysts, you have to know the meaning, the impact to the industry, and what are the ways that deactivation of catalysts could happen. So deactivation of catalysts could happen with these three ways, which is sintering, poisoning, and also coking. So you need to describe the meaning of sintering, poisoning, and fouling if there is questions in the examination. And maybe you can also include the graphic to further elaborate the meaning of the activation of catalyst through sintering, poisoning, and also coking.